Lesson 5-2, solving systems using tables, graphs, or a CAS calculator. Now, the solution to a system of equations in two variables can be estimated by examining a table or a graph and is often solved exactly by using a CAS. Now, we don't have a CAS. We have our calculator and table. But what I want to introduce to you as well is a Desmos. Desmos is something that's on your on a website. It's called www.desmos.com. And if you go to that, what I want to show you is Explore Math with Desmos. This will come up as soon as you type it in. You hit Launch Calculator. All right. And what can happen is right here in this 1, 2, and if you keep going, so on and so forth. But you can type in, oops, x plus 5 and get a linear equation. You type in another one. Okay. This is all y equals stuff. If you type in y equals 5, you get a horizontal line. Okay. So on and so forth. Okay. But then you can find out where these two lines intersect at. And actually, it's a pretty useful tool. Okay. That I had just found out last year when you guys were in geometry. So, going back to our 5-2, it says many strikes and no spares are in a bowling league in which players are ranked using a handicap system. The maximum handicap is 50 pins per game and depends on the player's average. Minnie has a high average, so she has a low 5-pin handicap. Noah has a low average, and his handicap is 45 pins. Noah practices, and his handicap decreases by 5 pins each month. Minnie does not practice, and her handicap increases by 3 pins per month. So after X months, Noah's handicap is 45 minus 5x, and Minnie's handicap, m of x, is 5 plus 3x. If the situation continues, then at some point Minnie's and Noah's handicaps will be the same. To determine when this will happen, you can solve a system of equations. Okay? Remember that a system is a set of conditions joined by the word and. Thus, if we call the handicaps y, the following compound sentence models a situation where the handicaps are equal. So they're giving you this system, and they want to find out when Noah's, this is Noah's, and this is Minnie's, they want to know when these two things are going to intersect. A solution set of a system is the intersection of the solution sets of the individual sentences in a system. So we want to see where they intersect at. Months is going to be my x, and my handicap is going to be my y. Excuse me. When we do this. So I'm going to show you the Desmos, how that works real quick, and then I'm going to show you the on our calculator. And I'll show you our calculator real quick, I guess. But you hit y equals. You hit y equals. And for some reason my calculator is not working. Okay, 45 minus 5x, and then 5 plus 3x. Now it all depends on what you prefer. I like tables, so I would hit second function table, and then I could scroll down through here and see when my y's are the same. And if you look at it, my y's are the same at when x equals 5. So I'm saying my answer is at 5 months, both of these people are going to be at 20. So at 5 months, they're going to be at 20. Now, let's look and see if my graph tells me the same thing, as it should. But my window's going to have to probably get a little bit bigger because I'm only at a -10 and they intersect at 20. So I'm going to make this 30 right here. And then I'm going to graph. And as you can see, they intersect. Now what normally happens here, and we've all had problems with this, is sometimes you have to round. It doesn't give you the exact answer. But if you scroll over here, as you can see, I'm having a hard time getting to it, but we can tell it's right around 5 or whatever. But this could give you a point to where to go look on your table to find out the real solution. What happens is, if you type these into your Desmos, okay, and all I have to do is remember these two things, 45 minus 5x, okay, 45 minus 5x, and 5 plus 3x. Okay, as you can see, and I'm just going to have to scroll out a little bit here until I can see where they intersect, and I'm just doing that with my toggle. But yeah, you can click on it right away. Boom, fairly easy, and you're going to find out for these problems, this Desmos graphing calculator is going to find you your solution a lot faster than anything else we have. But boom, right there, months is 5, your handicap's 20. Okay? So just another tool that you can use. How do you find solutions? Well, we just talked about that. You can use your graph, okay? Find out where they intersect. Bada bing, bada boom. And on your table, 5th month, 2020. Now, what's important is after you get your XY is that you have to understand what it means. Okay? In this situation, my X was months. Okay? And my Y was what their handicaps were at that time. So, although you find that intersection point, you still have to know what it stands for. There are 3 different ways to write your solution to this problem. I normally use the first one. Okay? I list the solution just as a coordinate point, 5, 20. You can write the solution set, okay? So you can make a set and put your coordinate points in there. Now, if there was 2 coordinate points where they intersected, you could say coordinate point 1, coordinate point 2, and your solution set. Or 3, you can write a simplified equivalent system. Make your bracket, x equals 5, y equals 20. Now, this is going to be difficult if you have multiple answers. And then if that's the case, I'd go back to my number 2. Okay? So, moving on. It says if Minnie's handicap increased by 5 pins each month, when would her handicap be equal to Noah's? So, now if you refer back to Minnie's situation, Minnie started at 3 handicap, I believe. Minnie started at 5, and they're saying if she increased by 5 at each time, right? So hers now is going to be 5 plus 5x is what m of x is going to be. So I'm going to go to my Desmos, and we're going to change this to 5 instead of 3. And now they're going to meet a little bit quicker and in 4 months. So my answer, when would her handicap be equal to Noah's? In 4 months. So just by increasing that, her handicap, it increased to a month where they intersect. Example 1 says, solve the system y equals 1/2 x minus 5 and y equals 2x minus 1. Now, you can type these into your Desmos. You can type these into your graphing calculator. I don't care what you used. You just need to go find it. A lot of times, as I said, you're going to find out your Desmos is going to work very well. Okay. The second one was 2x minus 1. And my first one, 1/2 x minus 5. Oops, notice how that messed up. I'm just going to put 0.5x minus 5. 0.5 is the same thing as 1/2 for all of you. If I go here and you can see they intersect right here at that point, which is a negative 2.67, comma, negative 6.33. And that is going to be my solution. Negative 2.67, comma, negative 6.33. I'm pretty sure. Okay, that's how easy it is, especially with that Desmos. Okay, so moving on. Hopefully it gave you another tool that will make your life easier. Example 2 says, Kayla is a packaging engineer for Healthy Soup Company. The marketing department has requested that she design a new soup can. The new can must hold 360 milliliters of soup and can be the shape of a cylinder. An eye-catching new label must be large enough to show the product name and all the nutrition content data. Marketing wants the area of the label to be about 225 centimeters. What are the dimensions on this new can? So the first thing is we got to know the formulas for area of a cylinder. So we need to know area of a cylinder. And we need to know volume of a cylinder, because that's what we have to hold, right? Okay, so we need to know those two things. So if you didn't have Mr. Johnson, guess what you would have to do? Probably look it up on your calculator, or on your computer, sorry. But since you have Mr. Johnson sitting right here talking to you, volume is pi r squared h. Okay? And for those of you that don't believe me, go ahead and look it up. Okay? Now, area of a can. Area of a can is 2 pi r h. Okay? So, what this is going to help me with is give me my two equations that I'm going to come up with. Okay? My area of my cylinder needs to be 225. So 225 has to equal 2 pi RH. Okay? My volume of my cylinder has to be able to hold 360. So my volume has to equal pi r squared h. Now, many of you are panicking. We don't have x, y's, etc., etc. Okay? What I need to do is I need to solve for one of these variables. Okay? Pi is not a variable. That's actually a number. So what I'm saying is I need to solve for one of these variables, so I need to get h or r by itself. Okay? And when I get h or r by itself, then that is going to be my y. So I guess if you're following along in your book, they solve for h. So let's just do that too. So if I solve for h, that means everything else has to get moved to the other side, so I have to divide by 2 pi r. So h equals then 225 divided by 2 pi r. I'm running out of room. And I got to solve for h on the other one. Okay, so here I got to get rid of pi r squared. So h is going to equal 360 divided by pi r squared. Okay? 360 divided by pi r squared. Now, in this case, h is my y. Okay? That's what I'm setting everything equal to. So, when we get an answer out, r comma h, okay? So r is going to be my radius, okay, of my cylinder can, and h is going to be my height. So we're going to find out using these two things, having this volume, having this area, what shape my can is going to have to be. So I'm going to go to our calculator to show you that we can put this in on our calculator. So y equals and we're going to type in 225 divided by 2 pi, and r is our x, so I put that in there. And on our second equation, this 360 divided by pi r squared, I got to make sure that they take pi times r squared first before they take 360 divide, because if I just write it straight through, 360 divided by pi and then times r squared, they're going to do the math wrong. I have to take pi times r squared, so you got to put parentheses around that. So 360 divided by pi, and put parentheses around that, pi r, which is my x, squared, parentheses around that. And I'm just going to go up here, I'm going to put parentheses around my denominator there too, just to be safe. Oops. Go back. Parenthesis 2 pi r, which is x. And that just keeps everything safe so they don't take 225 divided by 2 first and then multiply it by r and x. Okay? I'm just going to make sure that my window, let's just go zoom standard 6. So now they're going to graph that. And what you don't have to worry about is we don't worry about this stuff over here because that's negative stuff. So I'm going to get rid of my negative stuff here. 0. I might need to make my max a little bit bigger. Okay. But if I graph it, you can see that there was my first one, there was my second one, and they intersect right around. Now, if you wanted to do this on your Desmos, that would have worked too. They have pi and all that stuff on there as well. Okay. But as you can see, it's about 3.2 and close to 11. So our answer then is, and my tools disappeared on me. There they are. 3.2 comma 11. And so what that means is my radius of this is going to be 3.2, and my height is going to be, and we could probably round it to 11 point something. 11.2 maybe, or we could just leave it at 11 too. All right. Example 3 says solve the system y equals 4x squared and 2y plus 6x equals 14. Now, the great thing in all this is the simple fact that you have to solve for y. So 4x squared is fine, But for this one, you have to solve for y, so I got to get y by itself. So 2y, if I subtract 6x, I get 14 minus 6x. I divide by 2. And when I divide by 2, I got to do it to everything. So y is going to equal 7 minus 3x. So now I have my two equations, my y1, my y2. I go to my Desmos, okay? 4x squared. 4x squared is right here, this a2. Whoa. 4x squared. Gotta watch what you're typing in. Okay? And as you can see, you got a parabola, so it may end up being two solutions, so that's what you got to watch out for. Go right back here, 7 minus 3x, 7 minus 3x, and as you can see, it is going to touch in two different points, a negative 2, comma 13, and 1, comma 4. So, on your answer, you got to make sure you say that. So, you can have the set negative 2, comma 13 and 1, comma 4. So, you know that both those answers work for that problem. That's all I have for you today. Please enjoy. We'll see you tomorrow.